Very good morning to all of you, and I'm pleased to be here. And I'll be sharing some of my thoughts on how analytics is shaping our world. And I like this session to be far more interactive. A quick question on how many of you, us here, are data scientists by training or profession? Great. And how many of us have expertise in big data or some of the new technologies on deep learning? Anyone? Okay, great, thanks. So the analytics as a term stands is very old. It is not something which is like something which has happened just in the last few years. If you look at some of the technologies, they've been looked at for 40-50 years ago. Neural networks by themselves are not new. Speech recognition as a field is by itself not new. I started my journey about 17 years ago in IBM research in IT Delhi campus, and one of my areas of work that point in time was personalization and targeting for customers on the internet for some of the IBM's products. So it's a field which has evolved over last decade or so in something which has become really transformational for all of us, and it is impacting day-to-day life of everyone. It has moved out of research labs, it is moved out of academic community, it is now part of corporates, it is part of everyday life and what we experience in our interactions on a day-to-day basis. So what really is changing in last few years? I think the advent of mobile devices is something really important from analytics point of view. And this is something which is so important for businesses because they are able to reach customers on an individualized, personalized basis. If you look at a desktop, 15-20 years ago, it was still a machine which will be used sporadically in parts maybe by many people. One machine may be shared, but here is a personalized device which is used by consumers on a day-to-day basis, maybe 24 hours a day. And I just give you some data point. And we look at the Naukri job seeker app, and we see a spike in traffic early in the morning at 6:30 a.m. and we see a spike in the traffic at 10 p.m. in the night. So you know the usage pattern is no longer 10 a.m. to 6 p.m. It goes across the whole day. And then when we see those spikes early in the morning or late in the evening, it is telling us that the usage pattern is very, very different. It is far more personalized interaction. If you look at the number of people who have access to smartphones over the globe, it's more than 3.5 billion. And that number continues to increase every day. And just imagine, it is not just one application, there are multiple applications available on the device. They know who the customer is, they know where the customer is, they know the interest categories. If I'm actually using e-commerce app and searching for a refrigerator, or am I searching for an air conditioner, or am I searching for a mobile phone, I'm leaving my footprints behind, and the company or the application which is powering it knows what my interests are. If I'm actually ordering for diapers, they know how old is my kid, right? If I'm ordering some stuff on e-commerce which is very, very specific to a particular age group, they know the related family members whom I'm probably ordering for, and that knowledge keeps on adding itself. So it's more interesting if people start looking at what are the behavioral patterns, the interest categories of individuals, and then personalize the interaction for the customer. So that's the most interesting bit, if I say, in last few years, which has really made analytics mainstream. Some of the things which have happened in last few years, one is obviously coming of age for speech recognition. As I said earlier, this is something which started in 70s. So speech recognition is not new by any means. But the general speech recognition for natural language, where people are speaking at random, that accuracy never crossed 80-82%. The number of percentage points in accuracy in 1975 to year 2000, the gains were only a few percentage points. But today, we have actually crossed the threshold of acceptability in terms of interaction in natural language with a device, and the accuracy is now at a point where you can actually say the machine can, with still some errors, can understand what a individual is talking to the device. If you know the context, if you know the interaction, now you have additional data set. There are many footprints an individual leaves from morning to evening, right? But the spoken interaction is probably the largest amount of data that the person leaves in terms of its footprints when it comes to interaction, right? So just imagine if people are enabling speech, one, they're making it easy for interaction to happen with the device. They're also making it easy to capture data in terms of individuals' own preferences. Actually, this is not just the mobility piece which a self-driven car will create. It will actually create a lot of technologies in its own path. First, to understand objects in a moving vehicle, those objects which may or may not have been seen, may or may not have the same shape and size, and these objects have to be recognized by a self-driven car at real-time with a responsiveness which is really critical, because it is life saving and life determinant. It can be detrimental to life also if a mistake happens on the identification of the objects. So that is really critical from a technology point of view, and it enables many things on its way, because it will mean a lot of improvement in image recognition in terms of objects have to be quantified, databases have to be created in terms of what particular objects can come up in on a particular road. And then it is not just one location. We're talking of self-driving cars, not just in cities but across outside the city. So it is not as if someone who is selling a car can limit the scope, the breadth and width of the car, where it goes and where it does not go, right? So the object identification, image recognition, processing it in a real time, right? And it is something which is life of the vehicle and the owner depends on it. So it has to have a fairly high, I would say very high accuracy, right? It is something, if it goes wrong, can be terrible for the person and the occupants. So what we see is not just progress in data science. What we are seeing is thresholds in accuracy being crossed, which is what I want the audience to take away from, which is saying there are thresholds of accuracy being crossed in some of the interactions that we have with outside words, which makes it so valuable in our day-to-day interactions. If you put up a CCTV camera on a red light, that camera can now record not what's happening, it can also identify objects, it can also go and send information back. We have already challans being cut on using cameras without human intervention, right? So there is improvement happening across the board. And then we were also discussing medical imaging, and this is not a problem which is being addressed today. Medical imaging and AI as a machine learning, these problems are more than 20 years old. If you look at any standard data sets which are available for data science or machine learning, you will find 90% of the time they are somewhere related to radiology or images. They are the most commonly available data, and that's the first problem data scientists attract about 20 years ago. So it is something that the data is available in plenty, and then variety of data is available. There again we see accuracy is where the thresholds are being crossed, and that is what makes data science very interesting at this point. And I'm just taking an example from my own organization, Naukri.com, and that's something that we have worked very hard in terms of improving the experience of candidates as they come and visit our app. We get more than about 5 million hits on our recommendation engine in the app on a daily basis, and we are looking at spending more time understanding the text of the job and text of the profile that people have uploaded on our system. And that's an ongoing effort that we have created in terms of understanding what the designations are, what the skill sets are, what are the organizations they are working for, what are the institutes they have graduated from, what are the characteristics which are associated with these entities, and can we do a far better job of recommending jobs to candidates who come and visit our platform. And what we have seen is huge gains whenever we improve the accuracy by a few percentage points. And this is an ongoing effort. And as we see, data science and business benefits are not delinked. That there is a very close correlation. We have experimented over last 4, 5, 6 years in this space in many ways. And in every experiment, when we have moved accuracy above a few percentage points, we have seen huge business gains in terms of number of people who come back again and again, people who repose trust in the app in terms of delivering the most relevant jobs for them. And we see this from the data that we capture, from the applies that we get on jobs, from the CVs they update on our platform, and we have seen traffic share gains because of that. It is really impacting not just business rewards, it is also impacting competitive position in the market. So there are big gains happening because you apply analytics in a way which impacts consumers directly. So what is the key takeaway? One, better customer experience means more money. So there is no denying this fact. If you deliver more value to our customers, they engage more, they deliver you more value, and you can charge them more, you can price them much more. Data science is no longer in academia or research lab, it is mainstream. If any organization is not investing in data science, they are not investing in their future, they will get eliminated either by making bad use cases of their data, or competition will come and eliminate them, right? Customers will get a better experience wherever data science is being used, simply because if you know more about the customer, and if you're not customizing the experience, you are actually not making good use of what you can do. And there is no dearth of talent here. There is enough talent available in data science. It's hard to find them, but if they are available, they can make really huge difference. Any thoughts anyone wants to share? I have a few slides, but I can take a few questions also. Anyone?
You mentioned about the customized experience.
Yeah.
So we always hear about customized experience and user experience. Now you are introducing something called customized experience.
So yeah, sorry, go on.
You say that for example, you showed an example of your own sales manager. So when you say customized experience, when I use the app or recommendation, I should feel that I'm getting the right information. What do you mean?
Yeah. So I customize, personalize, there are many phrases to describe it. Now, question is not, there are obviously many things that you can do as a business, right? So first, you need to define how your customers behave and how different they are at different touch points. And then you say, what are my levers of control? What are the things which I can change? What will make a difference? What will not make a difference? So these are like saying I have 20 email templates and I use one email template for one set of customers, another one for another set of customers. I have different messaging, different communications, and I'm improving my marketing ROI. That's one example of customizing experience. And then you say customization moves to personalization, where you're actually saying I'm not doing on a segment level, I'm doing on an individual one-to-one level, right? So it depends on what are the levers of control that you have, right? So when I actually say in the app, right, if I'm actually changing the order of presentation of which will appear on the top, and we do that today, right? For example, if people who come to our site are just passed out of their college, they will see different pieces on the app versus someone who has actually spent a few years in the corporate world, because we customize the interface to give more information which is more relevant for that audience. But when I say personalization, I could actually say every customer who comes and sees unique jobs. And I actually personalize not just basis on what they have told us, we personalize on basis of their behavior, on what jobs they have applied, what jobs they have given negative feedback on, what preferences they have set, and things like that. Yeah.
Do you have a personal experience on ROI and what rate of ROI change you have seen in your work or any other's work that you want?
So the way I see it is we used to have a traffic share of 50% among the job portals about 5-6 years ago, and today we have a traffic share of 76%, and data science has played a large role. Obviously many other things we have done in 4-5 years, but data science has played a large role in us gaining traffic share. So the gains are enormous. Now question is, how do you quantize it, or in money terms? And these is obviously, there are no science behind, or there is obviously science, but there is no perfect or the only way of quantizing it. Okay. But it is something not really hard for people to see the connect, because if you are you can build an algo, you can also define metrics to measure it. So that is something which I always tell my data science team is saying 50% of the effort should actually go on defining what the problem is, what is the metric of measurement, and then demonstrating success. If you do not demonstrate success, you don't get investment again from the business.
Okay.
Any other thought? Yeah, sorry.
Can you give us some examples of some specific data science methodologies which you're using at Naukri.com, which has actually helped you, gain market share and, essentially forward the organization?
So I guess it all starts by understanding how the segments are behaving, and we start looking at defining customer segments first, and then you start looking at whether these segment behaviors are very different from each other. So it is, a methodology first is to go and understand what the data you have. I'll actually have a slide coming later, which will talk a little more about what we focus. There are 4 dimensions which I actually say are very, very important from analytics point of view. And if you're making progress in any one of the 4 dimensions, you will have success coming your way. But obviously it depends on how do you tie the customer problem to the business. So actually, if I just step back and say, 6-7 years ago, we used to do efforts on analytics side, but more on the periphery of the business. So we used to do stuff like predicting the payment propensity of customers, and stuff like customer value modeling in terms of lifetime value, and that was more on the marketing and the acquisition side. And then we said we are going to focus on now the core of the business, and the core of Naukri business is bringing the candidates and the recruiters together. And then we say we focus on the problem which the whole business is actually centered on solving, which is having a candidate find the best jobs for him or her, and finding the most relevant candidates for a recruiter, and which is essentially our data science problem. How do I recommend jobs to a candidate, or how do I recommend CVs to a recruiter? It's by nature of our business. We are actually a data science organization. But I'll answer your question in a little more detail, because I have a slide coming up there.
Sure, thanks.
And that's it actually, that's the one which is coming up. So I define 4 dimensions of how we make progress in it. One is obviously the data that we capture. If you don't have data, obviously you can't really build something out of it. Second piece which I would say is essentially domain expertise. Do you understand what customer is looking for? Why he does what he does, right? If a candidate is coming on the site and doing a particular behavior, it is to also understand not just what data you are capturing. You may be not capturing some things. So you sort of have to supplement data that you're capturing, as well as with customer discussions, interviews, maybe some surveys. Understand the intent, and then go back to data and saying, why am I not capturing this? So can I actually move from unsupervised setting to a supervised setting? Can I actually bring the behavior of the candidate or the recruiter in our context, or maybe the customer in other context, and use it as an element I can guide my prediction with, right? So that's where the journey has been. So we have been creating more data capture points. For example, we never used to have a feedback on the jobs that we used to require. Now we have, do you find this job relevant? Yes or no. A very simple yes, no. But the volume tells us a lot. And then we started capturing this feedback at an individual level, right? And since we actually have a substantial profile data, then we were able to segment and then say, banking segment, this is what the feedback is. Manufacturing segment, this is what the feedback is. IT, this is what the feedback is. BPO, this is what the feedback is. And then you can slice and dice by junior or the people who just passed out of the college, middle in terms of experience. Then you start doing slicing on locations. So there are multiple variables you start slicing and dicing on. And then you start building on what are the techniques which we're using here in terms of algorithms. And we started with linear regression, logistic regressions, went to neural networks, to random forests, to deep learning. So all of that is a journey that we have been at, right, in terms of expanding the nature of algorithms that we use. And then a lot of stuff we ignore here in terms of deployment, right? So let's not ignore deployment here, because if you are going to do it in real time, when a person comes to my app, and just after he comes to the app, he changes his profile. He changes his designation. He updates his profile. I got to actually recommend basis his updated profile. If he does and applies to a job, I want to change my recommendation in real time because I know more about this person now. I will never be able to give a real-time experience to my customer. So I just wanted to again think a little more on here. This is my take on what will bring us progress in the space. Another way to look at it is data science. When it explodes, it's not only this piece which delivers value, because we sort of tend to focus here, but we forget here. In terms of data collection, right? What are the levers possible for you in terms of collecting data? How do you collect? So for example, we started doing a 5-point scale feedback, and we realized that the feedback volume is so low. Now question is, do I need the granularity of 1 to 5 scale? Can I simplify a yes-no scale or a 3-point scale? And my volume of data shoots up because I made it easier for people to give feedback. And we realized that even the 5-point scale, most of the feedback was on the extremes. So it was either 1 or 5. So what's the point of having a 5-point scale? So the distribution tells you much in terms of data collection. The volume is also really important, because if the volume is not there, you can't really do something substantial with it. So you can't really slice and dice it by a segment, or you can't slice and dice by different customers, both sides. So on the recruiter side as well as on the candidate side. So my only point here is I'm saying is, it's not just here alone the value creation happens. Value creation happens here, value creation happens here, and value creation happens here when you move forward in your data science journey. That's my humble vision. So what are the kind of roles which are evolving in this space? And I sort of go back to my previous slide, is to say that wherever the value creation is happening, we will see new roles emerging in that same space. And I just picked up some jobs which existed on Naukri, and I just put them up here. So there are jobs like data scientists. Obviously there are a large number of them, and then more jobs then less people there. So that's again a very happy situation for all the data scientists here. There is obviously demand for natural language processing. There are demands for statistical modeling, big data developer, machine learning, applied engineer. Now just imagine this, just see the difference in this. People are essentially saying applied engineer. So it is not about someone who is doing theory or someone who is building academic papers. There are a lot of companies who are actually in the applied space. But there is also an interesting product manager search and discovery, product manager recommendations, and consultant machine learning. Now, these are the interesting, which is what I go back to my previous slide. How do you get the domain knowledge inside your data science team? And this is probably one role which is started to bring that domain knowledge in. How many of you agree with that domain knowledge is important from data science point of view? Okay. So thanks. I think this is one piece which we miss. See, a lot of times you essentially put the data in, put some algorithm, and come up with something which really works better than random, right? Because you have done some data, you have done some algorithm, you are better than random. But that does not mean you have gotten the best output of your data. Because you got to understand where the data is coming from, what's the meaning of it, what the segments it is, what is the use cases, why people are doing what they're doing, and then you apply what is the right algorithm for the right segmentation. And then you see a huge benefit with 2% gains in accuracy. So the one thing which you should realize is 80% is not same as 85%. You may think that there is only 5% gap. Actually, the way I see it is the error rate has come down from 20% to 15%. So that's a 33% jump rather than 5% jump on 80, which is less than 10, whatever it's like 6%. So it's such a 33% reduction or 25% reduction in error rather than 6% improvement in accuracy. So there are some learning and certifications are available right now. As the field expands, as we see there is a shortage of people, there are enough courses available on the web, and I see a lot of people already doing these courses, which are self-study courses and certifications. One data point I just wanted to share is that recruiters tend to prefer certifications more than just courses. So you may not want to ignore, if you are picking up skills in data science, don't ignore certifications. As career professionals, your certifications do help substantiate your value for a recruiter, and that's something you should not ignore. So in summary, my summation is that data science is transforming life. It is no longer in academia, no longer in research lab. It is part of real life now. It is impacting everyone around us and us included. So we cannot just shy away from ignoring, we can't just ignore it, and it is something which is mainstream now. And I think I read a quote on Twitter, machine learning is probably replacing Microsoft Excel on CVs. So knowing Microsoft Excel and knowing machine learning probably is something which is going to be as important as knowing Microsoft Excel. Thank you.
For this presentation. To Mr. I would like to welcome. Thank you, sir.